Hey, welcome back to the first video in this series. The first non-introduction video. Today we're gonna continue and start implementing the deep learning part in our Halite III bot. And to start out, I actually want to look at the changes that are already committed but have not written the tutorial yet. And also overall, the written tutorial is what I aim for. This recording is just because I want to see if maybe watching me do this, including all the screw-ups, bugs, and stuffs that don't work, could be somehow interesting as well. And I hope you saw the previous video or maybe read the tutorial up to now. I won't explain too much about what happened previously anymore. Just one thing, in order to now use a model instead of our QLearning, we can take the QTable bot, which is actually something I should fix. It should be the QLearning bot, and copied it to a neural network bot. And if you check the last commit, the changes that we need to make to the QTable bot is, okay, we now don't pass a table file name anymore, but the model path. This is minor. Here's some minor change to formatting. Now we import TensorFlow because we want to load a TensorFlow model instead of a JSON dictionary. And we say, okay, Keras load model. And then in the current queues, let's see where this is moved. This is more for debugging purposes. For debugging purposes, because I thought the print statement that we had with the QTable was quite nice, and I would want to keep this with the neural network, but we only make predictions in the main loop, so we store this too. We have a couple of cases. One case is the ship can't move, so we just default the move to standing still. So there was no choice. Our epsilon was chosen in a manner that we actually make random moves. And if that's not the case, then we actually use our model to predict. We take the argmax over those predictions, and then down here this is the bottom part where once the game is finished, instead of training our QTable or learning our QTable, we now just iterate over all the state action pairs, and in this case we just log them. We print out the total reward. This is maybe something I want to use to or maybe we should even use this in the file name, which is actually also something I see here is not correct. So I want to take the total rewards and maybe put them into the file name as well, so that at the end we can see if our bot is actually learning something or getting better. So in the first iteration we run with an epsilon of 0. Or 1.0. We run whatever 500 games. We get the total reward over those 500 games, and we the average reward over those 500 games, and then we can compare this to what happens if we set random moves to 0 and see if our model is actually starting to beat random, and so on and so forth. So this is the changes that we need to the bot for now. Probably in this episode we're going to make a couple more changes. Apart from that, we now need to code the part where we actually create the model, where we store the initial model, and where we train the model. And this is what I want to do today. This is actually my previous project where I already ran all of this, but here I want to start from scratch. And I will probably copy quite a bit of code because, I don't want to rewrite everything. But yeah, let's just see. So the way I imagine this working is we're going to have a training.py file, and we will first create a Keras model, initialize it, save it somewhere, and then call our bot passing this initialized model and see if this runs. And then in the next step, we're gonna go further. And to do this, I will actually copy something from over here, namely my create model function. Maybe we're gonna change this later on, but for now, this is exactly the code that I want. So to go through it real quick, do we need, I don't even know if we need all of these functions, dense, output, dropout, whatever. Let's just leave it for now. The backend is not used, so okay. Create model. Let's just remove this from, no, actually I want this to be a function. So here we should actually specify our experiment name. So or let's call it model path, I don't know. Model path or model name. How do I want to do this? So in my previous version, I just gave it some name based on how many layers it has, blah blah. This time I thought I want to somehow be able to manually change some parameters of the experiment and automatically create new models doing this. So let's go simple and then make it more complicated once we get there. And then experiments, okay. Let's leave it at this for now. So, and then FOS path exists, model path. If not, then we need to do create model. And here we want to have a model equals, if it exists, we load it. Or do we need to load it? We need to load it. Okay. Create model. Currently, this takes an input size and an output size. I'm going to go through this code in a second. Do we want to keep it like this? I guess so. And input size should be, let me just think, how did I do this over here? I manually, yeah. Okay, let's keep it similar for now. This is something I want to change in the future, but anyway. Field size. We can start with a smaller field. We did 8x8 in the QLearning experiment, so let's stay with this. So, and then input shape is going to be the number of features times field size. So we have these feature maps, field size, and then 5 of those. And then we have our input shape and output size. Output size is going to be we up, down, left, right, still, so 5. So this create model function, okay. Let's move this to the top. Let's go step by step, and then we're going to change the model immediately too. So what am I doing here? I create a model with an input layer which contains input size shape, which we just saw would be our matrices. Then we have a convolutional layer for now. I'm going to change this in a second. Batch normalization, rectified linear activation. And then 3 of those. And then we flatten everything, connect it to 2 dense layers, and then to the output layer. We compile with mean squared error. The metrics we track is accuracy, which actually doesn't make much sense because we're not actually trying to classify something, but we're actually trying to predict the proper future reward. But yeah, and then I should import. Should import TensorFlow. Here we use it. Keras optimizers. Adam. Yo, this is good for now. If this doesn't work, then we do models, load model, model path, model. So this should already kind of work. One thing is, if the path does not exist, we actually should model path. Whatever. We need to make this folder, and then we can try if this works. Initializing TensorFlow always takes a second, and this seems to have worked. As you can see, this is initializing TensorFlow, and then you see this is our model with all of its layers, a total of 400,000 parameters. Okay, and one thing that we want to do right here is Keras model save. We immediately want to save it to the model path. I wonder what's the parameters of save model. Just 1 second. How do we save? Model.save. Na gut, that's easier. Model.save into the model path. Okay, cool. So now if we run this again, and this should work. Immediately, this is our first model. Funny. Warning. Let's just see if using Keras path constraint. So it seems to have loaded this model as well. It's funny, I never saw that this was folders before. Maybe this is new in TensorFlow 2 or whatever the version is that I have. Okay, cool. Then good. Now we have the model. One thing we wanted to try is if we can call our game. For now, we're going to use os.system. Later, I will change this to pipe open. Command this one here. We want to, well, maybe it's fine. So this will be our command. Halite, our seed, replay, directory, turn limit, and this one, and this one, and this is the first bot, and this is the second bot. Okay, cool. And here we immediately want to, do I have to specify this up here or probably down there? No. This is defined by field size. And then we automatically okay, cool. Let's keep it at that. And here we run the bot and we give it as parameters. Our bot wants us to pass the model second, epsilon first. Which reminds me, we need to pass an epsilon. Epsilon. So starting epsilon and model path. Let's see. Seed is not defined. Ah, yeah, uppercase. Seed. Oh yeah. We also need to pass this. Oh yeah. See, it's initializing the player. Okay, and then we got an error, which should have left us with an error log, timed out. Why would this bot time out? Bot 0 log. What is my bot doing? Yeah, so two things that we should actually immediately fix is we put these two down here, because as soon as you call game ready, it will count for, it will make your turn count. So if you load a model or something that takes a little bit longer before it will time you out. That's one thing. We can immediately in our training file also fix that there should be no timeout. No timeout, because we don't care how long we take. And then by moving this around, why is there one? Okay. Killing. What's the doesn't define around? Okay. One more second. Why is there two bots? This is also not correct. Interesting. I need to check this in a second. And command. Let's just see what we're doing. Probably there's some space too much somewhere. Python 3, Python 3. Okay, this looks okay. And then Halite, there should be a no timeout. That's how I wrote it, right? Oh, tricky. So let's see. Okay, and then we still have some error here. Let's just delete those. And then down here, why are these strings? I wonder. I think this is not going to be as nice because current queue. Let's just see how this looks. Yeah, and this is the next thing I thought. Where there are only 2 non-keyword arguments accepted. Somehow we passed more than this. Oh, yeah. We need this one, and then this is probably why this looks so funny. Model path. Yeah, let's see how this will look like. We will fix this path in a second. I saw it earlier when I explained about how we do this, that this will not work. Exception, first dot model not found. Oh, yeah. So this one creates the model, it loads the stuff. No such directory. Good. Okay, 1 second. Now we're gonna do this. The model path that we're gonna pass is actually gonna be model underscore path to be consistent, and then it will be the now let's call it model path, and then so what I want to do is I want to have these I want to store the training data in the same folder as the model, which should be in the experiments. So what I actually need here, I want to have an experiment name, and this would be first try, and then I want to have a model name, which is something I'm gonna fill later automatically, and this model would be first, or just, actually I don't need a model name, I just need an experiment. What's the difference now? If our model path would be this one, experiments, experiment name, and we will also just call it model in here, not OS path exists, experiment name, OS path create, and OS mixture. I don't know now. Experiments. Experiment name, something like this. Experiment path, make their experiment path, and then this one is gonna be experiment path model. This is where our model lies. And we say if the model path doesn't exist, we create a model, and then up here we want to put our experiment path, and then in here I will infer. So currently this is the exp path, and then sharing path is equals f experiment path, and then training data, and then epsilon. This one. Is this something I should create outside maybe? Yeah. This is what we're going to do outside. Here we want a training data path and the model path. And then this one will be 3. Yeah, okay, for now we're always gonna have it, whatever. And then here we want the training data path. And then this one will actually be /total reward dash time. How did I do this part over here? 1 second, I want to somehow have the timestamp. I'm just gonna take this as well. So this one will be to make a unique timestamp so that we don't override stuff that has the same reward timestamp. Cool. This one looks okay. Now we wanted to change this, so we actually pass the starting epsilon, the model path, and the training data path. And then training data path needs to define training data path equals experiment path / training / so this one no, training data path, okay. Yeah, genau, exactly. Our training data path is the experimenting path, training, and then epsilon. Yeah. No? Okay, we passed. It's the general training data path. Over here, we bring epsilon into play. Too many places where we create folders, but I really want to store training data for varying epsilons. Probably we also want to separate this by epoch later. Training data path. Let's fix this later. So we want to have the epsilon in there. Total reward. Okay, now we still use model experiment game ready model path. This should be the model path. Also here. Okay. Okay, all good. Let's see what it does. We at least get to the point where we have a model, we have a training folder, cool. Now let's actually call our command. Game has ended. We run an episode for 10 steps. We get a reward of 4, which seems to be nice, I guess, because it's positive. How can this be? Let's check here. Did we get a replay? No logs. What replays? So the latest replay should be us. And we also should have a log, actually, which we don't, but let's just see if we can watch this. You saw that I have some other videos that I'm building. This is the wrong one. We want these ones. This one should be the newest. Yeah, so our bot returned 11 and made a total of the first round is no move, second round is no move, I think. Yeah, could be good. The only other thing we need to figure out is why it's not moving. And 1.0, this means we had an epsilon of 1. We only do random moves. We have our model, we have our experiment. Then there's one more thing, which I saw in Stack Overflow the other day, which is Stack Overflow find chaos model summary as string. I want to actually store this somewhere. Well, we can do this. So we open the file summary function. We can pass a lambda which takes file and write plus new line. Cool. Maybe I can do this here, and then we're going to end this episode for now. Next episode, we're going to change this network to actually be like in the DeepMind paper, but I know that this network for sure can learn something meaningful. Yeah, so if we create a model, we want to have model summary and then print fn equals lambda x with open okay, this is the wrong spot. We shouldn't do this here. We should do this here. We created a model. And then model. Is it model path or is model path actually the model? Yeah, experiment path. Experiment path slash model summary writing F. I think it's a bit annoying. And then F non right. It's plus one. And then let's quote this. Okay, let's try this again. Remove this, bam. And then we can find out why our bot is not logging anything, maybe. Python training. First try, we have a model summary which contains our model, which is good because sometimes I forget what the model parameters were. Nice first try. We have a model here. We have some training data. Now it's -8, which means we just walked around, didn't do anything meaningful. Let's see if this works if we just run it a couple of times to create more training data. And then the really last thing I want to do in this episode is figure out if why we're not logging is one thing that would be interesting. And so dumb. I know why. And this is something that took me a long time to figure out, and also why I moved this game thingy up there. This is because if you call logging.info before the game is initialized, it will not have the proper logging set up, because in this game constructor, I will show it in a second. In this game constructor, they set up the logging configuration, and if you call the logger before, it will just stay in a broken state and not log anything. Then the thing we wanted to add is no timeout, and then it's not an issue. Oh, this was a good one. This is something we need to fix. Here we want to not call our bot like this, we want to call it like the model name. And 52, so nice. Okay. I said we're gonna do this, and we two more things. One is let's set the starting epsilon to 0 to see if actually using our network works. And here we can also see we have our log. Now I don't know where this stuff comes from. Maybe from TensorFlow or something. Unsure. But here we can see now we made a random move, then we can't move, then we make a random move, can't move. Yeah. So this was kind of good, right? It moved left or something, or down or up, couldn't move, and then moved back to drop this off. Okay, now let's fix this part so that the bot runs, and then I think this is a good point to stop. And then I'm also going to make a write-up of this, a little bit cleaner, maybe a little bit not quite as detailed as this video, but okay. Here we got 4 dimensions. We wanted to have 4 dimensions, but needed an array. So let me just check here. This is also something that gets me with TensorFlow all the time. I just figure I need to reshape it. State reshape 1 5. This sucks so much. Can I not just wrap this into another array or something? Let's see if this works. This is because we only have a single instance of our states. Does this work if we just tuple this? I don't know. So you need to put it in an array or in a tuple, or somehow make sure that it's not just shape 558, but it's 1558, so that you only have one sample of this. Dot reshape 1 state. Shape. Does this work in Python? This would be so ugly, but nice. This works. So what? Oh god! What this does is it takes the state shape and unpacks all of these integers into the parameters. We can even check on our random network what moves did it make. So this is with 0, 0, epsilon. It just always stands still. And you can see this is the prediction of the network. Actually, standing still has the highest reward. And then yeah, it doesn't do anything else. There's no updates of the network yet, so of course it doesn't learn anything. This was one thing. Let's also quickly, then this is a 45-minute episode or something, fix the name. Here, this is the model path, but actually we want to do split. This doesn't tell me anything about the model. Oh. Because I call my model file model now. And then model path split slash 1, maybe, I guess. I need to rethink how I store this. Experiments. Then it's 2. Then we get the first try as a name. Okay, and just so now we could parse these files and actually build averages and whatnot. Let me delete this one time to see that the whole pipeline is working. The only reason I spent so much time on this is because I basically already did like train the network in a bit more ugly and fudgy way. As you can see here, I just have like, oh, this is my initial model. I stored some epochs, and then if I liked it, I made a snapshot of it. But I want to now kind of automate all of this so that you can run many experiments. So now we rebuild our network from scratch. You can see that the log updated. Now we have a different prediction for our start. Yeah, this is true because it's the last one. Good. Anyway, I think we're set up now, and in the next episode we could start running this in a loop a little bit. So initially we just want to run random moves, for which I could actually, initially we just want to run random moves, probably with 2 of our networks. So we can actually do this. So we collect twice as many samples for both of the players. Technically, we want to vary the seeds in between. We want to maybe parallelize this so that we run 2 or 3 games at the same time, and then we just collect a whole bunch of training samples. And then we're going to implement our first deep QLearning stuff. And I think in my tutorial I wrote already, and if not, you can find everything here. I will write an introduction to deep QLearning. I think this is the tutorial that I will kind of use as a reference. Here they play Doom from the original Atari paper. We're gonna actually model this network. And then let's see, we're gonna implement experience replay and talk about it, and we're gonna use a target network. Basically, okay. I hope this is interesting to some of you, and I'm excited to continue.